Hello everyone and welcome to this course on Power Query and MCode. If you're here, chances are you work with Excel regularly. You might be dealing with data that comes from different people, different systems, or different files. And more often than not, that data is messy, inconsistent, and it keeps changing. That uncertainty and the rework that comes along with it is what this course is designed to eliminate. I will show you how you can use Power Query to automate your workflows, design systems that help you save tons of time. If you've already used Power Query before, this course will take your skills to the next level. The course will not only teach you how to use Power Query user interface, but really go one level deeper to show you what's happening behind the scenes, how Power Query processes data, and how to work with MCode confidently without feeling intimidated by it. By the end of this course, you'll be able to feel confident handling large and complex data in Excel or Power BI. You'll understand and work with MCode in a practical and approachable way and approach messy data problems with a clear and structured way of thinking. A key objective of this course is to help you shift how you think about working with data. Instead of building workflows that assume data will always stay the same, you'll learn how to design workflows that expect change so you can build solutions that are sustainable and versatile. This course is structured into short, focused lessons designed to fit your busy schedule. You'll get downloadable exercise files, animated explanations to build strong mental models, and practical demonstrations based on real-world scenarios. You'll also see how to use AI strategically, not as a replacement for thinking, but as a tool to translate your logic into clean, readable code. If your goal is to eliminate frustration, work more efficiently, and build Excel workflows that you can trust, then you're in the right place. Let's get started. One important concept that I'll be referring back to throughout this course is scalability. Let's first understand what that means. Think of a bakery near your home that's known for amazing best-selling chocolate cookie. If someone shared with us the recipe of that cookie, most of us could probably make it at home. Some of us might even make it better than the bakery. But would that mean that we could run a business as large as the bakery? Probably not. What sets the bakery apart from home kitchen is not just the taste. One of the key differences is the scale, their ability to produce hundreds and thousands of cookies every single day consistently. The same idea applies to many successful companies. It's not just about having a good product. Of course, having a good product is a very important factor, but it's about having systems that allow that product to be produced reliably and at a scale. Now let's bring this idea back to data. In data or business analysis, what often sets professionals apart is whether they can work with data at a scale or not. Imagine you receive data from 5 different files that needs to be consolidated. One option is to manually copy, paste, clean, and combine the data each time. That approach can work at a small scale, but as the volume, complexity, or frequency of data increases, this approach becomes slow and might not even be sustainable. Power Query gives your data work the scalability. You design the process once, and Power Query repeats it reliably every time new data arrives. And that idea that is building scalable, repeatable systems is one of the core focuses of this course. There are 3 core learning objectives you'll see running throughout the entire course. The first objective is to help you shift from a manual way of working to an automated, scalable way of working. Instead of repeatedly fixing the same problems file by file, you'll learn how to set things up once and let your workflows handle repetition and data change. This is the foundation of working efficiently with data at a scale. The second objective is to develop your critical thinking and logical reasoning skills. Real-world data problems are rarely clean or predictable. They require you to think about what assumptions you're making, what things can go wrong, and how your solution should behave when the data changes. This course is designed to help you think through those problems proactively and logically. The third objective is to help you learn how to code in a modern, practical way. You don't need to memorize syntax or write complex code from scratch. But you do need to understand what the code is doing and how to guide AI tools to generate the right solution for you. In this course, you'll learn how to translate your logic into clear instructions for AI and use AI tools as an accelerator. When you combine automation, structured thinking, and modern coding workflows, the result isn't just a speed. it's confidence and control. And that's exactly what this course is designed to help you build. In this video, I wanted to briefly walk you through how the course is organized and how I recommend to use it. The course is structured into 6 modules, and each module plays a specific role in helping you build both skill and judgment when working with data. In Module 1, we start by getting familiar with Power Query itself. Here, you will learn ETL framework, which is the core concept behind how Power Query works. Understanding this framework is important because it gives you a mental model for how data flows through Power Query before we start doing heavy transformations. In Modules 2 and 3, we focus on using Power Query Editor. Power Query can be used in 2 main ways. One, through the Power Query user interface, and secondly, through the M code which runs behind the scenes. In these modules, you'll learn how to use Power Query user interface, which is intuitive and easy to get started with. At the same time, we'll also discuss the limitations of relying on the UI alone, so you understand where things can break down as the data becomes more complex. Most of the limitations of relying on Power Query user interface alone can be addressed effectively using M code, and that's why in modules 4 and 5, we focus on the fundamentals of M language. Now at this point, some of you might be wondering, do you need programming background or will you be expected to write code? The short answer is no. This is where this course takes a different approach. We don't learn programming the traditional way. You won't be asked to memorize functions, remember syntax, or write long blocks of code. Instead, I'll teach you how to work with M code in a modern way using the help of AI. But to use AI effectively, you do need a high-level understanding of how the language works. That's why in modules 4 and 5, we first learn the fundamental concepts of M language, and once you have that foundation, you're in a position to collaborate with AI, guide it correctly, and confidently use it to build robust solutions. In Module 6, we bring everything together. This is where we apply what you've learned to real-world data problems. We'll focus on anticipating how the source data might change, identify where our assumptions can go wrong, and really designing queries using M code that are versatile and sustainable. And this module is about more than just Power Query. This is also where you actively develop your critical thinking and logical reasoning skills. You'll learn how to question assumptions, think through consequences, design robust solutions proactively. These are skills that don't just make you a better data analyst, they improve how you approach problems in general, how you reason through complexity, and how you structure your thinking. So by the end of this module, you're not just building solutions that work today, you're building a way of thinking that continues to add value as data changes or becomes more complex. The course is designed for 2 types of learners. First, those who are completely new to Power Query. If that is you, I strongly recommend going through the course in order. The structure is designed to gradually build both understanding and confidence as you move from fundamentals to more advanced concepts. Second, this course is also for those who already use Power Query through user interface and want to take their skills to the next level. If you're in this group, you may choose to start from Module 3, where we begin exploring more advanced transformations and the limitations. In terms of requirements to get the most out of this course, you should already be comfortable with Excel at a moderate level. Specifically, you should be familiar with pivot tables, lookups, if functions, basic text functions, and working with data using filtering and sorting. You don't need advanced Excel skills, but just enough familiarity so you can focus on learning Power Query without any friction. Hello and welcome to Module 1. In this module, we're going to focus on understanding what Power Query is and introduce the ETL framework, which sits at the core of how Power Query works. Let's start by understanding what Power Query is. Let's use a simple analogy. Before automatic coffee machines became common, making coffee was a manual process. You would grind the beans, measure the coffee, decide how much water, milk, or sugar you want to add, and then you brew it yourself or prepare it yourself. You could make a great cup of coffee, but it took time, and the result wasn't always consistent. Today, with an automatic coffee machines, you set up the recipe once, you define the strength, the grind size, and the quantity, and some other parameters, and after that, a single press of button gives you the same cup of coffee every time. The machine remembers the steps of the recipe and repeats them consistently whenever you need coffee. Power Query does the same work in a very similar way for your data. In most data-related roles, before a data can be used in a report or a dashboard, you need to do some data cleaning. You need to remove unnecessary columns, fix some errors, missing values, and overall reshape the data into a structure that can go into a report or a dashboard. And doing all of this manually is like making a coffee from scratch every single day. It works, but it's slow, it's inconsistent, prone to errors, and most importantly, it doesn't scale. With Power Query, you set up the transformation steps once, Power Query remembers them, and every time new data arrives, you simply press the refresh button and it takes care of the job. Just like coffee machine doesn't just make coffee, it gives you your time back, Power Query does the same for your data work. In this module, we'll build the foundation you need to understand how this process works before we start applying it hands-on. So let's get started. The first thing we need to understand is the framework that Power Query is built on. It's called the ETL framework, which stands for Extract, Transform, and Load. Sometimes you may also hear the term CTL, which simply means Connect, Transform, and Load. They both refer to the same underlying idea. Let's walk through these steps one by one. Extract is about connecting to your data. If you want to build a report or a dashboard in Excel or in Power BI, the first step is to bring in the data. That data might be in the same Excel workbook, it might be in another Excel workbook, might be in a database or an online resource. The extract stage is where you establish the connection between the destination workbook, that is the workbook where you want to set up the report, and the raw data. Transform is the second step, and this is where most of the work usually happens. Once the data has been brought in, it's rarely in a state to go straight into a report or a dashboard. You may need to do some data cleaning. For example, you might need to remove some unneeded columns, you might need to fix some errors, missing values, and overall bring the data into a usable structure. All of this cleanup and preparation happens at the transform stage. Load is the final step. Once the data is clean and ready, you need to load it into its final destination. In Excel, that might be a table or a pivot table on an Excel sheet. In Power BI, it's usually the Power BI's data model. So, in simple terms, Power Query follows this workflow. Connect to your data, transform it, and then load it. Understanding this flow is important because everything you do in Power Query fits somewhere into this framework. So in the next lecture, we'll start with the extract stage and look how Power Query connects to different data sources. In this video, we're going to learn about the first stage of the ETL framework, which is extract. By now, you already know that extract refers to the process of connecting to your source data. Let's assume I have this Excel workbook over here where I want to set up some report. The source data based on which this report will be made is over here in a separate file. I will open this file just to give a quick walkthrough. It has a very simple data set, just a few rows and some columns. I have kept it simple for illustration purposes. I'm going to close this file now and come back to the original file where we want to build the report. To connect this file to the source data via Power Query, I will go to the Data tab, click on Get Data, and then from Excel Work. Next, I need to provide the location of the folder where my source data is saved, and select the file. Here we need to tell which sheet on the selected file do we want to get the source data from. Our file has only one sheet, so I'm going to select that. And once we do that, we will get a preview of our data set over here. After that, we've got two options. Either we click on the load button or the transform button. If we click on the load button, it will directly jump to the third step of the ETL framework, that is, it will load the data directly into the Excel workbook. We want to go step by step, so let's click on the transform data. Once we do that, Power Query editor window opens up. This is where all the data cleaning and transformation work happens, and we'll be spending a lot of time here in this course. In this example, we're connecting Power Query to an Excel file. However, as you may have noticed, Power Query can connect to many other data sources as well when needed. Before deep diving into data transformations, let's do a quick walkthrough of the Power Query editor interface. In the middle, we have the preview grid, which shows the preview of our dataset. On the left, we'll see the queries pane. This shows all the queries that we are working with. You can think of each query as a separate data table that Power Query is preparing for us. If you connect to multiple files or tables, they will all appear here. Right now, we have connected to only one data source, so we can just see one query. At the top, you have the main ribbon with key tabs. Each tab contains different transformation actions you can use to clean and reshape your data. As we move through the course, we are going to work with all of these options step by step. On the right, you have the name of the query. If you want, we can change it as well. For example, I can, instead of sales data, I can put testing. Just below that, we have the applied steps pane. This pane records every action Power Query performs step by step. Each time you remove a column, split a field, or clean up an error, a new step is added over here. This is the heart of Power Query's automation, and we're going to explore it properly in a few minutes. For now, just keep in mind that every transformation we perform on our data gets recorded here in a sequence. Right above the preview grid is the formula bar. This shows the M code behind each transformation step. You don't need to know M code right now, but it's helpful to see what Power Query is doing behind the scenes. So let's explore the different steps that Power Query has applied so far for us. There are 4 steps in total, as we can see here. The first is the source step. In this step, Power Query is simply connecting to the source file. If I click on this step, the formula bar gets updated and shows the file path that we selected when we were connecting to our data. Next is the navigation step. Here, Power Query is going inside the file that we had specified and pulling the data from the sales data sheet. At this stage, we can also see the preview of our source data. After that, Power Query is promoting the first row of our dataset as headers. We did not create this step, Power Query added it on its own. And in the last step, Power Query is automatically assigning data types to each column of our dataset. For example, we can see that the product becomes the text, amount is assigned an integer or numeric data type, region is given a text data type, and so on. You can also see the assigned data types by looking at the small icons next to each column name. So that was a quick walkthrough of the Power Query editor. Now that you're familiar with the Power Query interface, we'll move to the second stage of the ATL framework, that is the transform stage. This is where we're going to apply cleaning and transformation actions. In this video, we're going to do some basic transformations to our data. First, I can see that the sales rep column has a lot of uneven spaces. I want to trim this column. So I'll right-click on the column header, go to Transform, and select Trim. Alternatively, with the column selected, I can go to the Transform tab, then under the Format option, I can select Trim. Notice that when I did this trim transformation, a new step got added in the Applied Steps pane. If we click on this step and look under the hood on the formula bar, we can see that some M code got generated and it is being applied at this step. Every time we perform a transformation action using the Power Query interface, Power Query writes an M code behind the scenes and records it as a step. Moving on, in the region column, I can see that the values are not properly cased, so I can right-click on the region column and uppercase it. Or, if I want, I can just capitalize each word. Again, a new step got created in the Applied Steps pane as we were doing these transformations. In the comment column, we have some indicators of which rows we want to keep for our final report or dataset and which ones we want to remove. So I'll go to the comment column, click on the filter, uncheck the remove, and click on OK. This will only keep the rows that we need for our final dataset and remove the ones that we don't. Lastly, let's say I don't want the comment column at all in my final dataset, so I'll select the comment column, press the delete key on my keyboard, and this will remove the column altogether from our data. Looking back, we can see that for each of the transformation we performed, a new step was being created and recorded under the Applied Steps pane, and behind each step there was an M code that was being generated and recorded as well. If you want to see the entire M code for all the steps in one place, we can go to the Home tab and click on Advanced Editor. Here we have the M code for all the steps we have performed so far. In the source step, Power Query is connecting to the source data using the file path that we provided earlier. In the next step, it's navigating to the sales data sheet inside the source file. Then it's promoting the first row as headers. Then it's assigning data types to each of the column in the dataset. After that, we trimmed the sales rep column. We uppercased the values in the region column. Then we capitalized the region column. Then we filtered the comment column to remove any rows that contain the remove comment. And lastly, we remove the comment column altogether from our dataset. I'm going to close the advanced editor window. Let's say if you want to remove any of the steps that you've performed so far, you can just click on the cross button next to the step name. So for example, I don't want to remove the comment column anymore. I changed my mind. So I will just click on this cross button and that step will be gone. If you want to add that step back again, you won't be able to use the Control-Z or the undo option like we have in the rest of the Microsoft Excel and many other softwares. You will need to add that step again. So I'll just select comment column, press delete again, and that step will be added back again. Notice that when we select a certain step in the Applied Steps pane, the preview grid updates to show the state of the dataset as at that point in the process. For example, if I select the filtered rows step, I can see that the comment column is still in there because at that stage of the query, we hadn't yet deleted it. The last step of the query shows the state of the dataset that will ultimately go into our final report. Let's say we are happy with the transformations we have done so far. Now we are ready to move to the next stage of the ETL framework, which is loading the cleaned up dataset into our Excel workbook. Now that we've performed some basic transformations, it's a good time to learn about two important concepts: Power Query's automation model, that is how Power Query automates the data cleaning process, and the importance of applied step sequence. You already know that all the transformations we did in the last exercise were recorded here in the Applied Steps pane as well as in the form of an M code. When the new data comes in, Power Query simply repeats these steps on the new dataset and gives you the cleaned and transformed output. This is what makes the process repeatable and scalable. The steps that we have defined here are recorded and executed top to bottom. This means that the step number 2, which is navigation in this case, depends upon step number 1. Step number 3, which is promoted headers, depends upon step number 2, which is navigation, and so on. If we reshuffle the sequence of these steps in a wrong way, it can break the query. Let's use the coffee example again. When making a coffee, you follow a particular sequence. You turn on the power, then you make sure that the ingredients are loaded, you place the cup below the dispenser, and then you press the brew or the start button. If you try to press the start button before turning the machine on, it won't work, because the steps must happen in the right order. Power Query works the same way. For example, in this query, the source step connects the query to the source file. The navigation step goes to a particular sheet within the file, and in this case, it's going to the sales data sheet. If you put the navigation step ahead of source, it will not work, because Power Query first needs to connect to the source file in order to know what sheets are in there, and then it can navigate to the required sheet. Similarly, let's take a look at the change type step. It's taking the name of each column and assigning it a particular data type. For example, the product column is given a text data type, amount is number, region is text, and so on. The change type step appears just after the promoted headers step. The promoted headers step is where these column names are defined, and these column names act as an input to the change type step. If we go one step before the promoted headers step, we can see that these column names were not there at all. We had generic column names like column 1, 2, etc. So in this case, the promoted headers step is a precedent step, and change type is the dependent step. If we remove the precedent step, the dependent will also not work. For example, if I delete the promoted headers, the change type step will break down. Because now the change type step is trying to look for columns called product, amount, region, etc., but it's not able to find them. And if one of the steps in your query breaks down, the entire query will not work. Even on the final step of the query, you will see an error. So if I go back to the navigation step, and between the navigation and the change type step, if I add the transformation to use first row as headers, it restores the same column name. And now the change type step will start working, and rest of the query will also work. To sum it up, every transformation we do in the Power Query editor is recorded in the form of an M code, which reruns automatically on refresh. The steps run in the order they are defined, so the sequence is important. Let's say we are happy with the transformations we have done so far. Now we will move to the last stage of the ETL framework where we load the data into the Excel workbook. Let's go to the Home tab and click Close and Load, and then select the option Close and Load To. In Microsoft Excel, we have a few load options available. You can load it as a simple Excel table, a pivot table report, or a pivot chart. There is another option called Connection Only. Connection Only means that the data would not appear on a worksheet in your Excel workbook. It stays inside Power Query and can be used later for combining and merging. We'll look at examples of this in a later module. I will go ahead with a pivot table report, and I'll select the existing worksheet, and I'll select the location where I want the pivot table to be, and click on OK. Now we have our pivot table. I'll create a simple pivot table using the fields on the right. From this point onwards, this pivot table becomes your output layer. Anytime there is a change in the source data, we just need to refresh the pivot table, and it will pull the latest data, run all the transformation steps, and return the clean result. Let's say we have a new data available now. I will go to the source file, and here I will update the dataset with the latest information. Then I will save the file and close it. Now, if I refresh my pivot table, it will grab the latest information. The load step for Power BI works a bit differently. Therefore, I wanted to walk you through that process. First of all, I'm going to connect my Power BI workbook to the same dataset that we used in the last exercise. Next, I'm going to do the same set of transformations that we did when we were working with Excel. So I'm going to trim the sales rep column. I'm going to capitalize the region column, filter out the remove from comment, and then delete the comment column. Now, as you can see, we do not have close and load option or close and load to option like we saw in Excel. Instead, we have an option to directly close and apply. Once I press that, our data will get loaded into Power BI's data model. Now we can set up our visualizations using this data. The refresh process works in the same way. If there is a change in your source data, you just click the refresh button and refresh a schema in data, and the updated information will appear here. Here's a quick summary of what we have covered in this module. We started by understanding the ETL framework, which forms the foundation of how Power Query works. You then learned how to connect different data sources and walk through the Power Query editor so you're comfortable navigating the environment where we're going to be spending a lot of time throughout this course. We also covered basic transformations and introduced an important concept around mental model and applied steps. You saw that every transformation you apply gets recorded as a step, and that Power Query executes these steps every time you refresh the data. You learned that Power Query works step by step, and that sequence of a step matters. We introduced the idea of precedent and dependent steps, which becomes especially important as queries grow more complex. Finally, we looked at the load stage, where transformed data is brought back into Excel report or loaded into a Power BI data model. In the next module, we'll build on this foundation and start working inside Power Query editor at a deeper level. Now that you have an understanding of the ETL framework, we're ready to go one level deeper into data transformations. In Power Query, transformations can be done in three broad ways. First is by using the Power Query editor or the user interface, which you already got a glimpse of in Module 1. Second is by working directly with the M code, which is the language that Power Query uses behind the scenes. And third is a hybrid approach, where UI generates the steps and you refine them using the M code. In this module, as well as the module 3, our focus will be on performing transformations using Power Query user interface. The goal here is simple: to help you become more comfortable and confident using the Power Query editor for everyday data preparation tasks. These are some transformations you'll find yourself using again and again in real-world projects. More specifically, in this module, we'll cover how to remove and keep rows using different filtering patterns, clean and reshape text data, split columns using delimiters, and work with data types and errors. These are foundational tools for turning raw data into clean, usable format. At the end of this module, we'll also load the transformed data back into Excel and take a moment to test and validate the results by refreshing the data. As you work through this module, don't worry about memorizing these steps or options. Instead, focus on building awareness and familiarity with what's possible inside the Power Query editor. Later in the course, we'll revisit many of these transformations and look at them from more advanced and design-focused perspective. So whenever you're ready, let's start with Module 2. In this lesson, we're going to learn about a few transformations that can help us clean up the rows in our dataset. The exercise files are provided in the Resources section. To start off, we'll connect Power Query to the first file in this folder, which is called Module 2 Remove Filter. We have the preview of our dataset. As we can see, the first row is empty. I want to get rid of this from our dataset. There are a couple of ways to achieve it. The first one is to go to the Home tab, and then under the Remove Rows option, I can select Remove Blank Rows. Alternatively, I can select Remove Rows and then select the option for the Remove Top Rows, and then specify the number of rows that I want to remove from a dataset from the top. Here I want to remove only the first row, so I'll put 1 and click on OK. Always keep an eye on the M code that is being generated behind the scenes. Sometimes the M code is not too difficult to understand. For example, in this step where we remove the first row, we can see that Power Query is applying a function called table.skip, and then it's passing an argument to skip the first row. Let's say if we want to skip more than 1 rows, I can directly go into the M code and modify the formula over there. So for example, let's say I want to delete first 3 rows of the dataset. I'll put in 3, press enter, and it will remove the first 3 rows. Let's go back and put only 1 again. So it only deletes the first row of the dataset. Likewise, we have other kind of options here as well. For example, if we want to remove the rows from the bottom, we can do that. Or we can remove alternate number of rows. On the other hand, we also have the option to keep certain number of rows. For example, if we want to keep the last 2 rows of the dataset, we can do that by selecting Keep Bottom Rows and putting in the number of rows that we want to keep from the bottom, and that will remove all the other rows and keep the bottom 2 rows. For now, I'm going to delete this step. We can also clean up the rows by using the filter method. For example, I want to remove the rows where status contains error. So I'll go to the status filter and uncheck error. Likewise, I also want to remove rows where the invoice column have a grand total. So I can do that too. If I want to filter only rows where the amount is above a certain value, we can do that as well. So I'll go to the number of filters, greater than, and I'll select the value threshold. For now, I want to keep only rows that are greater than 1000, and that will do the job. Again, if you want, we can directly modify the M code behind this step. Let's say I want to set the threshold to 800 only now. I can do that too. Filtering in Power Query is different from rest of Microsoft Excel. In Excel, filtering is temporary. It just hides the rows. The underlying rows of data are still there. In Power Query, filtering is permanent, and it creates a new step. Once you filter rows in Power Query, those rows are removed from the dataset for all future steps. So in this example, any row where the amount was below 800 is now gone. If I load the data into Excel at this point, only the remaining rows will be loaded. The filtered out rows will not appear in the final output. In this video, we're going to go through some of the text transformations. The exercise file for this lesson is called text cleanup. It's saved in the same folder where we have rest of the files. To connect Power Query to the text cleanup file, this time we can follow a slightly different approach. The text cleanup file is saved in the same folder where the remove filter file is. Therefore, I can duplicate this query, which is already connected to the remove filter file. I'll rename this query as text cleanup. Then I'm going to remove all the transformation steps that we had applied on this query. I'll right-click on Promote Headers and then delete until end. Now I can go to the Sources tab, and in the formula bar, I can change the name of the file. The rest of the file path remains the same. So now our Power Query is connected to the text cleanup file. If I go to the navigation step, it gives an error. The reason why it's giving an error is because the navigation step is trying to retrieve the data from a sheet called Sales Raw. The text cleanup file does not have any sheet called Sales Raw. Instead, it has a sheet called Customers. So in the navigation step, I'm going to change Sales Raw and replace it with Customers. Then press Enter. One of the things that Power Query does when we connect to the source data using the other method is that it adds a step to promote the headers. We can see that the Promote Headers step is not there, so we can add it ourselves. First of all, I'm going to cancel the Change Tab step, which was added by default. Then I'm going to go to the Transform tab and select Use First Row as Headers. Now we have landed to more or less the same position that we would have arrived at had we followed the other methodology to connect to the data. Next, we can do some text transformations. First of all, I want to remove any leading or trailing spaces from my dataset. For example, in this instance, we have a space before the name in Alex Lee. In some cases, we might have spaces after the names as well. These can be removed by using the trim function. So I'll select customer name, transform, and then trim it. If we want, we can trim multiple columns as well by selecting them together and then selecting the trim option. The trim option will remove the leading and lagging spaces in our text, but it will not get rid of the non-printable characters. For example, here we have a new line feed between the words new and York. If we want to remove these special characters, for example, the line feeds or tab spaces, we can use the clean function. We can also modify the casing of the text values. For example, if you want to capitalize each word, we can do that too. Or if you want to uppercase something, that is also possible. If you want to split a column based on some delimiter, we can do that as well. For example, let's say I want to split the customer name into first and last name. I know the separator or the delimiter in this case is a space. So I can right-click the customer name, select a split column, split by delimiter, and then put a space as the delimiter. There are other options as well that we could select. Click on OK, and the customer name will be split into two columns. I'll just delete this step. Alternatively, we can also extract certain data from the text values. Let's say I want to get only the first names of the customers and remove the last names. To do that, I will select the customer name, go to Transform tab, extract, text before delimiter, and put a space as the delimiter. This will leave us with only the first name because the transformation we performed got rid of all the characters after the delimiter, which was a space in this case. Most of the text transformations we did in this lesson are available on both the Transform tab as well as the Add Column tab. So what's the difference? Let's check it out. I'll first delete the transformation which we just performed. So we now have the full customer name again. And now I'm going to apply the same transformation by selecting the customer name, going to Add Column, Extract, Text before delimiter, and a space. Click on OK, and this will add a new column with only the first name of the customer. So the difference is that if you do a transformation using a command under the Transform tab, Power Query is going to overwrite the original data and return back to you only the transform data. If you do it via the Add Column tab, Power Query will preserve the original data and add a new column with the transform data. Let's have a look at a few more examples of a split column and especially the types of scenarios in which this transformation might be helpful for you. Let's connect to the split columns files. So I'm going to go with the same approach. I'll first duplicate the text cleanup file, name it as split columns, delete all the steps after the promoted headers, and then change the name of the file in the sources step. So I'll copy the file name from here, go to the sources step of this query, and replace it here. The name of the sheet from which we want to grab the data this time is called Orders. So I'm going to go to the Navigation tab. Instead of Customers, I'll put in Orders. And now our Power Query is connected to the source data. I'll remove the Change Type step. First, I'm going to promote headers, and then the Change Type step will automatically be applied. So here we can see that we have a column for product code, which is made up of 3 distinct parts. The first character represents the product family, the next 3 digits are the product number, and the last characters after that indicate the region in which they were sold. Let's say we want to break the product code down into 3 different columns. 1 column for product family, 1 for product number, and then for region. Because that might be helpful for our analysis. For example, if you want to see the sales for a particular region or for a particular product number. To do that, I'll select the product code column, right-click, split column, split it by delimiter, and this time for the delimiter, we're going to put in a hyphen, and I'm going to select each occurrence of the delimiter. So if the delimiter appears more than once, it's going to split the column into as many times as the delimiter appears. Click on OK. And now we can see that the product code column has been split into 3. We can rename the columns. So I will call this product family. This one will become product number, and this one will be the region. As always, keep an eye on the M code that is getting generated behind the scenes. Getting familiarity with M code at this stage will make it easier to grasp the concepts later on. If we inspect the M code for the rename columns step, we can see that it's renaming the product code 1 as the product family, product code 2 as the product number, and product code 3 as region. If we want to change any of the names we have assigned, we can do that directly in the M code. So for example, instead of region, I'll put testing, and the new column name will change accordingly. Let's go back to region, and that works too. Likewise, in the last column of this dataset, we have an order number, which is a combination of a product code, year, and market. If we want to split them as well, we can follow the same approach, split column by delimiter, and this time the delimiter will be /sign, click on OK, and this will be split as well. Again, we can rename the columns as we like. In the middle, we have a column which contains the name of the sales rep who are responsible for these respective products. Let's say I want to split this column into the first and last names. This time we do not have a space between the first and last name, so we cannot use a space as a delimiter to split this column. But no worries, Power Query has a feature to split these type of values as well. I'll select this column, go to Transform, Split Column, and select lowercase to uppercase. And that does the job for us. Now I can rename these columns. So in summary, splitting columns can help you split your data into meaningful components that could be helpful for your analysis. Next, we're going to look into data types and error handling briefly. Data types and error handling might sound basic, but they are actually one of the biggest reasons why Power Query models fail in real-world projects. If you learn how to handle data types correctly, your queries can become more stable and robust. So I'm going to duplicate the last query, and I'll call it data types. This time, I will delete all the steps after the change type step. I'm doing this on purpose because I want to introduce one error that happens quite often in the real-world models. So let's get to the sources step. And this time connect to the data types file. The name of the sheet inside this file is invoices. So I'm going to go to the navigation step and put the name of the sheet there. In the next step, the Power Query is promoting the headers. And if we go to the change type step, you'll notice that it throws an error. And this is because Power Query is not able to find the columns that are hard-coded in the M code of this step. Basically, this step is trying to look for the product code column so it can assign that column the text data type. This is because we created a copy of the splits column query where there was a product code column to work with. But when we apply the same step or same change type step on the data types file, it doesn't work because those columns are not there anymore. So for example, if I go to the promoted header step, we now have new columns. We have invoice, amount, quantity, discount. There's no column called product code, full name, or order reference. Remember the concept of applied step sequence? The change type is a dependent step. It is dependent upon the last step and will only work if the last step produces these column names which are hard-coded in the M code of this step. Since we have changed the source file, those column names are now gone and the change type step doesn't work. So I'm going to delete this step and reintroduce the change type step manually. I'll select all the columns, go to Transform tab, and select Detect Data Type. When we ask Power Query to detect data types, it looks through the data in the column and assigns the data type based on the column profile. So for example, for the amount column, Power Query has assigned text data type, probably because we have some text values in there. If you're not happy with the data type that has been applied by default, we can change it by clicking the square box next to the column headers. For example, I'll change amount to number data type. I'll do the same for quantities as well. And for discount, I'll put a percentage data type. If we force apply the data types, it can sometimes lead to errors. For example, here in the quantity column, we have an error. If we click on the error, it says that we cannot convert this value into a number. And the reason why it cannot convert is because if you go to the previous step, we'll see that over here we had a text value. It says 7, but it's written as a text. And Power Query is unable to convert this text value into a number. Same is happening with this error. We had a text value, and Power Query is unable to convert it into a percentage. In this case, you can decide how do you want to handle the errors. One option could be that you can remove all the rows which have errors. So for example, I'll select all the columns, go to Home, remove rows, and remove errors. Of course, that will lose the data in the other columns of the rows with the error because the entire row gets deleted. Alternatively, we can replace the errors with some other value. For example, with all the columns selected, I will go to the Transform tab, Replace Values, Replace Errors, and I can replace them with 0. Or instead of 0, if I want to replace the errors with a null value, I can do that too. I can go to the gear icon and I can write what value I want to replace it with. Or this time, we're going to sneak into the M code and write null in place of 0. Many times you might have to work with a dataset that is arranged in a hierarchical format, for example this one. This especially happens when you are picking up a data which was created using a pivot table, or sometimes it can even come from ERP or the accounting systems. We have a transformation feature in Power Query that can help convert these types of hierarchical data into flat tabular format. Let's go back to our Power Query editor. First, I'm going to duplicate the last query which we created. Then I'm going to rename this query I will connect this query to the next file in the folder, which is called replace fill. Then I'll change the name of the sheet. In the region column, I can see some blank cells. I want to fill up these blank cells with the correct item labels. So I can right-click on the region column, go to Fill and Fill Down. And Power Query fills each blank cell with the last non-blank value above it. Next, we're going to look into Replace Values feature. It's another commonly used feature. This is great for fixing spelling inconsistencies or standardizing your categories. This could be helpful when you know that in your source data there could occasionally be some spelling mistakes, and you want them corrected for your final report. For example, in the customer column, we have Acme Corp. I want to replace Corp with a full spelling Corporation. I'll right-click Customer, Replace Values. Value to find will be Corp, and replace it with Corporation. Once again, let's inspect the M code underneath this step. Instead of Corporation, let's say I want to replace with some other value. For example, I want to put Company. To do that, I can modify the M code directly in the formula bar. Press Enter, and that should update the values. Sometimes, system might give you transactional level detailed data, and you might want to summarize it. In this lesson, we're going to explore how we can do that using Power Query Editor. First, let's connect to the next file in the folder. So I'll duplicate the last query, rename it, delete all these steps, go to the Source tab, copy the name of the final file, and replace it over here. The name of the sheet in this file is Sales, so I'll go to Navigation and update the name of the sheet here. And that should give us the preview of our dataset. So this is a quite detailed data. And let's say I only want to see sum of amount by region. I can do that by selecting the region column, go to Group By. Name of the new column, we can keep it amount. And then we need to define what operation we want Power Query to do on the amount column. So as I said, I want to see the sum of amount for regions. So I'll select sum. And the column which I want to be summed is the amount column. Click on OK. Instead of sum, if you want to see an average, we can do that too. I'll click on the gear icon and select average here. Or alternatively, we can directly manipulate the M code as well. This M code is slightly more complicated than the previous ones, but if you eyeball through the M code, you can see that it's applying some function here, which is called list.sum. Instead of sum, I'll just try and see if there's a function called list.average. And it appears that there is such function. So I'll just select that and try my luck. And yeah, it does work. If I want to go back to sum, I can do that again too. If you want to do aggregation based on two columns, that is also possible. So let me delete this step. Let's say I want to see the sum of amount by region and customer. So I'm going to select region and customer columns, both of them together. Then go to Group By. Again, for the new column, this time we can give a name new column. And we want to get the sum of amount column. Click on OK. And that does the job for us. If I want to revert back to the single column aggregation, I can again go and change the settings using the gear icon. Or this time, I'll just remove the customer name from the M code, and that should do it. We are pretty much done with all the basic transformations that I wanted to cover. We can now load all the queries into this Excel workbook. So I'll go to the Home tab. And this time, let's load all of them as a connection only. Later on in the course, we will also see the use cases of loading some queries as connection. Let's say we want to load one of the queries as a table. So I can right-click on this query, select Load To, select Table. It can be on the existing worksheet. I'll select the cell where I want the table to appear and click on OK. And there we go, we have the data. As discussed before, these transformation steps are recorded and will be applied to the new data as it becomes available. To test it out, let me go to the source file, which is connected to this query. I think it was the first file. And here, I will add some extra data at the bottom. I'll save the file, close it. Now let's try refreshing this table. And the new data should become available after getting cleaned. This brings us to the end of Module 2. In this module, we focused on getting you comfortable in working inside the Power Query editor and using some common cleanup and transformation techniques through the user interface. You also got a brief hands-on exposure to M code by looking at and lightly modifying the code that was generated by UI-based transformations. This is an important bridge and practice for what's coming later in the course. Also, most of the transformations that we did in this module were applied to a single dataset, but in real-world scenarios, data often needs to be combined across multiple tables, files, or sources. So in Module 3, we will start working with those kind of situations. Also, as the data becomes more complex and unpredictable, relying on user interface alone can introduce some limitations. So in Module 3, we're also going to take a look at those limitations. You'll start to see where UI approaches can break down and why understanding what's happening behind the scenes becomes increasingly important. So whenever you're ready, let's go to Module 3. Welcome to Module 3. In Module 2, you learned how to use Power Query user interface to perform common data transformations. In this module, we'll start working with more complex, real-world-like scenarios, situations where transformations have to happen across multiple tables, files, or sources. You'll learn how to append data, consolidate files or folders, merge data from different tables, and reshape the data structure. As part of this module, I'll be introducing some important concepts and terminologies. We'll talk about what are tall tables and wide tables. We'll explore different types of pitfalls like split column pitfall and rename column pitfall, and we'll also learn about silent versus the blocking errors. These terms are important because I'll be referring to them repeatedly in later modules, so building a clear understanding at this stage will make everything that follows much easier to grasp. We'll also explore situations where UI-generated transformations may not stand the test of time. You'll see how queries can break unexpectedly or produce incorrect results, especially as the data becomes more complex or unpredictable. The goal of this module is not to discourage you from using UI altogether. It's to help you understand its limits, see why certain issues occur, and recognize when a solution that looks correct on the outset might not actually be. This awareness is critical because once you understand where and why things break, you're in a much stronger position to design solutions that are predictable, scalable, and safe. Although this module mainly focuses on working through the user interface, understanding the pitfalls and shortcomings of the UI-based transformations is essential for appreciating the purpose of modules 4 and 5, where we start working more directly with M code. In those later modules, you'll see how many of these issues can be addressed through better design patterns and deeper understanding of M language. In this lecture, we're going to look at how to combine tables using the Append feature in Power Query. Imagine you're a business analyst working in the sales department of a particular company. You receive sales files for different months from one of your colleagues, and you have to consolidate them into one pivot table. So we've got the sales files for Jan, Feb, and March here. Let me open one of these files to give you a quick overview of the data structure. It's a simple dataset with 4 columns that show sales amount and quantity by product. The other 2 files also have a similar structure. Our goal is to create one pivot table that has data for all the months in one place. We can achieve that using Power Query. Let's go ahead and set up a new Excel file. I will name it Sales Consolidated. Then we will connect this file to each of the monthly source data file using Power Query. So I'll go to the Data tab, get data from Excel Workbook, select the Jan file first, I'll rename this query as January, then I'll duplicate this one, rename this to Feb, and in the source data step, I'm just going to change the name of the file. Rest of the folder path remains the same because the files are saved in the same folder. That should hopefully work. Now I'm going to do the same for the March. So we've got 3 tables loaded as separate queries here. If I load them in Excel right now, they will get loaded as separate tables or separate pivot tables, which is not what we need. We need one pivot table that has all the data in one place. And for that, we will need one query that has data for all the months in it. We can do that by using the Append feature. With any of the queries selected, I'll go to the Home tab and then Append Queries and Append Queries as New. Then I'll select 3 or more tables. January is already in there. I'll select February and March, and then click on OK. This will create a new query called Append, and inside this query, we will have the data for all the months in one place. We can rename this query to Consolidate. Let's have a look at the M code that is being generated underneath. Basically, it's combining 3 tables called Jan, Feb, and March. If you want to combine only Jan and Feb, you can go to the M code and modify it. And as we can see, this will result in a combination of only Jan and Feb data. If I want to add any table, I can just write it separated by a comma in the M code, and that should work too. I want to do one more quick transformation, and that is I will go to the individual queries and remove the change type step from each of the individual queries. And then I'm going to add the change type step as the final step in the consolidated query. So I'll select all columns, transform, and detect data type. This will ensure that we don't have multiple change type steps in our setup. When we were appending queries, we saw there were 2 options, Append Queries and Append Queries as New. The Append Queries option will append the data from other queries at the bottom of the currently selected query. So for example, I have January query selected right now. If I select Append Queries, and then I select the February query, it will stack the February query data right at the bottom of the January data. If we go with the Append Queries as New option, like we did before, then it will create a new query that has the combination of data from all the other selected queries. For now, I will cancel this step because we want to go with the append queries as new option, and we have already created a new consolidated query here. Now we are ready to load this consolidated query into our Excel workbook as a pivot table. So I'll go to close and load to. For now, I'm just going to load all of these queries as connection only. And then for the consolidated query only, I will right-click, load to, and load this one as a pivot table report on the existing worksheet. Click on OK. Now we have the data for all the months loaded in pivot table. If the source data changes, the update will appear here with a single refresh. Let's test it out. Assume your colleague tells you that the March file has been updated with some additional sales. Let me open the March file. I'll add a few extra rows of data in this file. Save it and close. Now if I come back to my Excel and refresh the pivot table, it should pull the new data and show the updated totals immediately. So basically, the append feature stacks different tables on top of each other. It helps in data consolidation. However, you have to be careful about some points when appending tables. The first thing to remember is that Power Query decides how to combine columns based on the column names and not the column position. So for example, if column sequence is different across the tables, but the column names are identical, Power Query will successfully combine the columns. But if the column names are different, it can lead to two types of pitfalls. First is the split column pitfall. For example, in the January file, the sales column is called amount, but in the February file, it's called sales value. When we append these tables, Power Query will treat them as two different columns. And in the consolidated table, we will have an amount column as well as the sales value column. The January rows will have the values under the amount column and blanks under the sales value. February rows will have the values under the sales value and blanks under the amount. This creates a broken, inconsistent output and can make your final reports inaccurate. Let's see this in action. I will go to the March file and I'm going to rename the amount column and change it to sales value. I'll save the file, come back to our consolidated pivot table. I'll try to refresh it, and you will see that the March sales value is gone, which is not true. We have the sales number for the month of March. We got it from our colleague in the file, but it's not showing up in the final result, which is making our result inaccurate. Let's look under the hood to see actually what's happening. I'll go to Queries, double-click on any query. In the January query, we have the 4 columns as expected. The February query is also doing fine. We have the same 4 columns. But in March, we have a newcomer here, and it's a new column called Sales Value. So when we append the tables, Power Query keeps both the column names in the consolidated result, and it splits the data across them. That's why January and February fill the amount column, and March fills the sales value column, and that's why we call it the split column pitfall. This error doesn't only happen when the column names are spelled differently. Even a difference in a letter casing can break the append because Power Query is case sensitive. Let me show you an example. I'll close the Power Query editor. I'll go back to the March file. This time I'll keep the column name as amount, but I'll type it in all caps. Save the file and close it. Now if I refresh the pivot table, it still doesn't work. And that is because Power Query treats amount spelled in uppercase and amount spelled in propercase or lowercase as two different column names. So the question is, how do we fix this problem? One option could be that we go to the March file and correct it there. but this option is not scalable. If you're working with only 2 or 3 files that have only a few columns, you can definitely do this. But if you're working with a large setup, for example, you have 20 files each with 30 to 40 columns, then these spelling mistakes will be so often that every time you'll end up spending hours correcting the source data before you can refresh your query. And as we discussed in the introductory module of this course, our objective is to make queries that are scalable. So this option doesn't work for us. Another option could be to simply correct the column name in the March query itself, because that's where the problem is coming from. So let's try that out. I'll go to the March query and rename the amount spelled in upper caps to amount in proper case. Notice the M code that gets generated behind this step. Power Query is looking for a column called amount with upper caps and renaming it to amount in a proper case. Now, if we check the consolidated query, everything works again. We can press close and load, and hopefully the pivot table will also work as well. If I refresh it, we see the data for all the months, including March. So far, so good. But here's the issue. Imagine the person who was preparing the March file says that there is some update and they want to send you a revised dataset. And this time, they name the amount column something completely different. So I'll go to the March sales file again. And let's say in the revised file that they sent to us, they renamed this column to amount_final. I'll save the file, come back. Now when we refresh the query, the whole query breaks down. Let's look into the model to see where the error is coming from. I'll open the consolidate query, and then we get a message that an error occurred in the March query. The column amount of the table was not found. Let's go to the March query and start inspecting from the first step. The source step was working fine, navigation was fine, promoted headers worked okay as well, and then the error happened at the rename column step. This is because the rename step is looking for a column called amount spelled in uppercase, and that column no longer exists. This connects back to the concept of applied step sequence, which we learned about in the module 1. Rename column step is a dependent step, and promoted headers is the precedent step. For rename column step to work properly, it needs a table with a column called amount spelled in upper caps, but the precedent step is no longer producing it. For the purposes of this course, we're going to call this pitfall the rename column pitfall. And it happens because when you rename any column using Power Query Editor or Power Query's user interface, it produces an M code that has a hard-coded value for the column names. If those column names are gone from the updated dataset, the rename column step will break down. One way to solve this problem could be to tell Power Query to look for a column called amount in upper caps, and if it finds it, convert it into amount in proper case. But if it's not found, then don't worry, just move on. We can give this instruction by writing a simple expression right before the final bracket or the closing bracket. It's called missingfield.ignore. Now Power Query will do exactly as I mentioned. It will look for a column called amount in uppercase, but if it's not found, it will not break the query, it will just move on. So now our March query looks fine, it's working properly, but this lands us back to the same error that we saw before, that is the split column error. If you check the consolidated query, you'll notice that the columns are now split because we have a new column called amount_final. To fix that, I would need to add yet another rename columns step in the March query. And this is where this approach starts to fall apart. This solution is not scalable. Every time a new file arrives with a slightly different column spelling, I would have to keep updating the rename step in the final query, which is clearly not efficient, neither scalable. So what's the best way to solve these kind of challenges? In an ideal world, the answer would be to have a data structure agreement with the people who are sending you these files. This means aligning upfront on things like how many columns will there be in the source data, what will be the exact names of those columns, and how the data should be laid out. But unfortunately, based on real-world experience, I have to say that this approach hardly ever works. You might be able to get some level of compliance, but not consistently. People don't always pay attention to small details, they may have different levels of Excel skills, and sometimes new team members might join the organization who might not be aware of the data structure agreement at all. So we need a more reliable approach, and this is where M language comes in quite handy. Using M code, we can design robust queries that are stable and can handle these kind of challenges intelligently. When I say robust, I don't mean to say that your query is never going to break down at all. Of course, if there is a drastic change in the source data, for example, if the entire structure of the file changes or entire data or the file gets deleted altogether, then of course your query is going to break down. What robust means here is that we design queries that anticipate and handle commonly occurring structural changes gracefully. For example, minor differences in column names, changes in the column order or sequencing, a few new extra columns appearing, or some expected columns missing altogether from the source data. These types of changes are very common in real-world data, and our queries should be able to deal with them proactively. Before we wrap up this lecture, there's one more pitfall which I want to cover. Earlier, I mentioned that inconsistent column names can create two issues. The split column pitfall, which we already looked into in quite a lot of detail, and the second one is the skip column pitfall, which we're going to discuss now. The skip column pitfall happens when a column exists in one of the tables, but Power Query skips it completely when appending the two tables and producing the final consolidated output. Here's an example. In the January table, we have 4 columns: product, month, quantity, and amount. In the February table, the first 3 columns are consistent: product, month, and quantity. But the 4th column is called sales value instead of amount. When we append these tables, Power Query will only include the 4 columns from the first table. In this case, it's the January table. This means that in the consolidated table, it will bring in the data from February table for product, month, and quantity columns, because those columns have consistent names in the February table. But in the amount column, it will have blank values for the February rows. This is because February table doesn't have a column called amount. With split columns, at least you can see the extra column. With a skip column pitfall, the data is silently dropped, and you may not even notice that February sales values are missing. We'll look at an example of this pitfall in the next lesson. Let's recap the learnings from this lesson. When you append tables, Power Query matches columns by name and not by position, so even if the column order is different, as long as the names match, the append will work correctly. If the column names are not consistent, it can result in a split column pitfall or a skip column pitfall. If you try to fix the split column pitfall by renaming the inconsistent column names using Power Query user interface, you might run into the rename column pitfall, where the query breaks when the source file changes again. These pitfalls make your queries unreliable, error-prone, and can lead to inaccurate results in your final reports. The ideal solution to these challenges is a data structure agreement with the coworkers who are sending you the source files. But when that's not possible, which is quite common in real workplaces, you can design robust dynamic queries using M code with proper check and balance mechanisms. We'll explore these techniques later in the course. In the last couple of lectures, we combined 3 tables, Jan, Feb, and March, using the append feature. Now imagine we get the file for the next month, that is April sales. Of course, we want the April data to be in the same combined pivot table report. One way to do this is to create a new query for April, like we had done for other months, then clean that query, and then go to the source step of the consolidated query and add April as the 4th table over here. This should work, but it doesn't scale. Next month, you might get the data for May, then you will get it for June, July, August, and so on. And you don't want to keep creating new queries and editing your append step manually every month. And imagine if you're consolidating the sales data on a daily or a weekly basis, this problem will quickly compound and eat up a lot of your time. What we really want is a solution that automatically picks up all the files that are inside a particular folder, apply the same transformation logic to each file, and then append everything into one clean table. If a new monthly file arrives in that folder, we don't want to touch the query, we just want to hit the refresh button and it should work. Let me show you a quick demo of this. I have a consolidated pivot table here. Currently, it has January to March data. Once the April data becomes available, I'm just going to drop the April file into this folder, which I have connected the Power Query to. Now I'm going to go back to my pivot table, and without touching the Power Query at all, if I just refresh it, the April data should flow in as well. To achieve this kind of setup, we'll need to connect Power Query to a folder rather than a single Excel file. Let's set up a new Excel workbook. And this time, I'm going to get the data from a folder and give location of the folder where I plan to save every month's file. Currently, our folder has only 3 files, that is Jan, Feb, and March. So those are visible in this window. I will go ahead and select Combine and Transform Data. In the next window, we need to select a sample file. So what is a sample file? You can say that a sample file is a file based on which we will define our transformation steps. Whatever transformations we will define on this sample file, Power Query is going to apply those steps to all the files in the selected folder. For the sample file, we can select any file from the 3 that are currently available, Jan, Feb, or March, or we can go with the default option, which is the first file. Also, we need to specify which sheet should the query pick the data from. All of our files have the data stored on sheet 1, so I will select that. Then I will click OK. And this should open the Power Query editor. We can already notice that this time Power Query editor window looks slightly different. We have some extra queries added here on the left. Let's not worry about anything right now and just load the query into the workbook as a pivot table. Now let me create the pivot table. I'll put the month in the rows and amount in the columns. Currently, our folder has files for only 3 months, so that data is rolling in here. Now let's test out if the setup is working. I'll go to my main folder, which I had connected the Power Query to. And here, I'm going to drop in the April file. Now let's go back to our pivot table and refresh it. And the setup works. Just to test out once more, if I remove the April file, let's say, and then refresh it, the April data will be gone. Now let's do a bit of inspection of what's actually going on under the hood. The queries you need to know about at this stage are the sample file query, the transform sample file, and the append query. The other 2 queries, parameter and transform file, support the automation, but you don't need to modify them yet. We'll cover parameters and functions later in the course, after which they will make more sense. Let's click on the sample file query. This query is referring to the file which we selected as a sample file when we were setting up the folder connection. Remember, we selected the first file in the folder. The first file in our folder is February sales file because the files are arranged in the alphabetical order, so it's showing the February file here. If instead of the first file you want to refer to the second file, you can go to the M code and change 0 to 1. Somehow when I keyed in 1, it actually opened the file, so I will cancel this step. And now we can see the January sales file. If I want to refer to the March file, I can key in 2. And it will show the March file. This brings another important concept to remember. In Power Query, the indexing starts from 0 and not 1. So if you want to get the first item in the folder, you'll key in 0. For the second item, you will put in 1, and so on. Let's go back to the original position, where the sample file was the first file in the folder, that is February. Now let's move to the transform sample file query. As the name indicates, this query is taking the sample file, which we saw in the last step, and performing some transformations on it. For now, it has only 3 transformation steps, that is source, where it's connecting to the sample file, then in navigation, it's going to the sheet 1, and then it's promoting the headers. If we want, we can add more transformations as well, but for now, let's keep it simple. Next is the append query. This is the query that has all the data from all the files consolidated in one place. Let's deep dive into its steps. First is the source step, where this query is simply connecting to the folder that we had specified. Look at the preview grid at this step. We can see that we have 3 files inside this folder, and we can also see some properties of these files, for example, date modified, date created, etc. Next is the filtered hidden files. This step filters out hidden files, ensuring that temporary files or system files do not get loaded or cause errors during folder consolidation. Next is the invoke custom function, and this is a very important step. First, you can see that as a result of this step, a new column called transform file is produced. Basically, in this step, Power Query is taking each file in the folder and applying to it certain set of transformations. What transformations are being applied? The transformation steps which we defined in the transform sample file query. And as a result of these transformations, a clean table is being produced, and those tables are stored in the transform file column. If you want to view the cleaned up tables that are being produced, you can simply click on any of the cell that contains the table, and you'll be able to see the preview of the data inside those tables right here at the bottom. For example, this is the cleaned up table from the February file. This one is the cleaned up table from January. And here we have the cleaned up dataset from March. If you want to view the fill table in a separate query altogether, you can right-click on any of the table and add as new query. So for example, here you can see the full data from the month of March. I don't need it for now, so I'm going to delete it and go back to my append query at step number 3, where we were before. In the next step, Power Query is renaming the name column to source name. So as you can see, at this stage, this column was called name. Now it has renamed it to source name. All of these steps are added by default. We did not create them. After that, it's removing all the columns and leaving only the source name and transform file column. And lastly, Power Query expands all the tables inside the transform file column, so all the rows from all the files appear in one consolidated table. And as a last step, Power Query assigns data types to each column. If you want, you can add more cleanup steps to the transform sample file, and they will automatically propagate to all the files in the folder. For example, let's say I want to replace the word keyboard with keypad. I'll go to the transform sample file. As you might have guessed, we will use the replace values function. Instead of keyboard, I will write keypad. Click on OK. Now when I come to the append query, the transformation has not only affected the February file, it has affected the data from other files as well. Now let's check how robust our queries really are. Let's say you receive a revised file for the month of March, and the person who prepared it accidentally misspelled amount by adding an extra T. So I'll go to the March file, and just to demonstrate what I'm saying, I will add an extra T to amount. So here the amount is misspelled. I'll save the file, close it, If we refresh the query now, pivot table shows that March has 0 sales, which is not true. So let's inspect what happened. I'll go to the append query, and then I'll go to the invoke custom function step. Let's have a look at each one of the cleaned up tables. The February table looks fine. January is also doing okay. The March table, when viewed on its own, is also doing okay. We can see that the amount column has values in the March table, and also notice that the amount column is misspelled over here with an extra T. So each of the table is coming through properly when viewed on its own, but the problem happens at this step of the append query where all the cleaned up tables are being combined. This is where the amount data from March table goes missing. This is the skip column pitfall, which we discussed about in the last lecture, and here's why it's happening. Basically, in this step, Power Query is first setting up the column headers, that is product, month, quantity, and amount. How did Power Query decide that these are the column headers? It looked at the headers in the sample file, which is the February sales file in this case, and took the headers from that file as a standard column headers. Then it goes into each of the table and tries to pull the data from those exact column names. For January and February, it's able to find all the 4 names, so everything loads correctly. For March, it finds product, month, and quantity, but it's not able to find the amount column because over there, the 4th column is misspelled. So March sales values are skipped completely, and the amount column for March becomes blank. Again, the ideal fix for these kind of data challenges is to have a data structure agreement with your coworkers. But when that is not possible, we need to build guardrails using dynamic M code and proactive checks and balances, which we're going to learn about in the upcoming lessons. In the last few videos, we learned about combining tables using the append option. In this video, we're going to explore the merge feature. Using append, we can add more rows to our table or expand our tables vertically. With merge, you can add more columns to your table or expand your tables horizontally. We're going to work through an example to understand why would we need to merge queries and how can we do that. As always, the exercise files for this lecture are provided in the resources section. Let's go ahead and open the sales file. Imagine we have this data set which shows sales values by product code. In a separate Excel file, I have loaded this data set into Power Query. I haven't done any major transformations, as you can see from the applied steps. So I'm just going to close the Power Query. Here is the pivot table. And the pivot table shows us the sales by product code as we would have expected. But let's assume we don't want to see the sales values by product code. Instead, we want to see sales by category name. The problem is we do not have category name field in this pivot table. And neither do we have the category name column in the query based on which this pivot table is created. If we could add one column to this query that shows the category names, that will solve our problem, and we'll be able to see the sales by category in the pivot table as well. So we do not have the category name in the main dataset, but I have another Excel file that has the mapping of the product codes to the category names. If we could bring in the category names from this mapping file into the main table as a new column, that should do the job for us. And this is very similar to how we would use a VLOOKUP or XLOOKUP in Excel formulas. In Power Query, you can achieve the same result using the merge transformation, or let's say by merging the two tables. First of all, I will need to load the data from the mapping table file as a separate query. So let's go ahead and do that. I will click on New Source, File, Excel Workbook. Then I will select the Product Master file. Let's promote the headers. And this looks good. Now that both of the queries are here, we can go ahead and merge them. There are a couple of terminologies you will need to remember related to merging queries. The table you want to bring the new information into, or the table in which you want to add the new columns, is called the primary table. Sometimes you will also hear it called the fact table. In our case, the primary table is the sales table. And the table you are pulling the information from is called the lookup table, or sometimes also called the master table. In this example, that's the product master table. To merge queries, I'll go to the primary table, then I'll go to the Home tab, and then select Merge Queries. This opens a new window where we have to choose two things: the tables we want to merge and the matching columns that link those tables together. So the sales table is already selected. For the second table, I'll select Product Master. Now we need to select the matching columns. So what are matching columns? If you have used VLOOKUP or XLOOKUP in Excel, you know that the first argument of these functions is the lookup value. That is the field that exists in both the tables. Matching columns work the same way. These are the columns in the primary table as well as in the lookup table that contain the same identifiers. Power Query uses these matching values to combine the rows correctly. In this case, the columns that contain same identifiers or same values in both the tables is the product code. So I'm going to select that in both the tables. Next, we can select the kind of join that we want to perform. There are different types of joins available. We will look at them shortly. For now, you can leave it at the default option, which is the left outer. Then click on OK. After that, Power Query adds a new column to the main table. This column is called Product Master, and each cell in this column contains a nested table. Let's open one of these tables to see what's inside. Each nested table contains the matching rows from the Product Master table for that specific product code in the primary table. For example, the first row in the primary table has product code A101. So the nested table in that row shows the part of the Product Master table that corresponds to A101. The second row has A102. So the nested table in that row shows the data for A102. Coming back to our objective, we only need the category names here in this column. So how can we do that? We can click on this button at the top and expand all the nested tables that are there in this column. The nested tables contain three columns: product code, product name, and category. We just want the category name for now. So let's uncheck the other columns and click on OK. Now we have the category names in a separate column. Let's load this query. Our primary table is already loaded as a pivot table. So now it's asking about how do we want to load the Product Master table, which we just freshly added to the Power Query. We do not need the Product Master data table on our Excel workbook. We just loaded it into Power Query so we can look up the category names from it and bring it into our sales table. It's a supporting query, so I will just load it as connection and click on OK. So as you can see, the sales table is loaded as a pivot table. Product Master is only a connection. Now inside this pivot table, I should be able to see the category name field. I can remove the product code, bring in the category, and now I'm able to see the sales values by category. Now let's strengthen our understanding by looking at a few watchouts you need to keep in mind when merging queries. First, I'll add the product code to the pivot table so we can see both the product codes and their categories side by side. The first watchout is that for a merge to work, the matching columns must have a consistent format. That means that the values should have the same casing, they should have no leading spaces or trailing spaces. If the formats don't match, the merge will fail for those rows. Let's see an example. I'll open the Product Master file. And I'll change one of the product codes to lowercase. So I'll make A101 in lowercase. And for A102, I'm just going to add a couple of spaces towards the end. Now I'm going to save the file, close it. Now let's refresh the query. You'll notice that these two product codes no longer show the category name, and that's because Power Query can't match them anymore. If you open the sales query, you will see that all the other product codes match correctly, but these two product codes do not because Power Query is not able to find the matching value for these product codes in the product master table. Now I will close the query. And let me go back to the product master table. And I will undo the changes. Save it and close. Refresh it again, and it should work. The second watchout is about duplicate values in the master table. If the matching column in the master table or the lookup table contains duplicates, Power Query will create duplicates in the primary table as well, and this can make your totals inaccurate. Let's walk through an example. First of all, let's keep an eye on the total amount for product A101 in the pivot table. It is 184, which is correct. It's coming from the sales dataset, and we can verify it from there as well. Now I'll go to the product master table. And I'm going to duplicate the product code A101. I'm going to save the product master table, close it. Now I'm going to refresh the pivot table. And once we do that, you will see that the total for A101 has doubled. So why is that happening? Let's open the sales query to understand and inspect the steps. First, I'll go to the change type step, which occurs before the merge query is a step. At this step, we can see that we have two rows for product A101 showing amounts of 1200 and 684. So the total is 184, which is correct up to this point. At the merge step, we still have only two rows. The merge itself hasn't duplicated anything. But when we come to the last step, which is expanding the nested table from the product master data, both rows get duplicated. We end up with 1200 twice and 684 twice. The total becomes double, which is incorrect. Let's go to the merge query step and drill down into the nested table for product A101 at this step. And here we can see why it's happening. Power Query is picking up two matching rows from the product master table, and that is because we created a duplicate there. In the last step, when it's expanding the nested tables, it's bringing in the duplicates over there as well. This is where merge queries works differently from the lookup function in Excel. In the lookup function, if there are duplicates in the values in the lookup table, the formula fetches only the first value. But in merge queries, it can create a duplicate records. Therefore, as a best practice, you should always remove duplicates from the matching column of your master table. And for example, if I right-click on this column and remove duplicates, now the data in our primary table will also be correct and there will be no duplicates. I will click close and load. Refresh the pivot table, and it should again show the correct value. Another watchout to keep in mind is the missing values in master table. Again, let's walk through an example to understand this. First, I want to remove the product code from this pivot table and leave only categories. Now I will go to the sales table . Here I'm going to add a new product code, E800, with some dummy values. Now I'm going to save the file and close it. Note that E800 is a new product and it's not yet available in the product master data. Now if I refresh the pivot table, we will get a blank category. And if we put the product code against the category, we'll see that this blank category is coming from product code E800. The blank values on your final pivot report might not look good, so a better way to handle it would be to replace it with something like category not found. Let's go into the sales query. Here we can see all the merges are working fine except for product E800. And the reason for that is E800 is not defined in the product master data at all. Therefore, for the E800, we are getting a null value. To fix this, in the last step of the sales query, I will replace null with a category not defined. Click on OK. Now I'll load this query. And that should remove the blank and replace it with category not defined. In the last video, we learned about how to merge queries, and we mainly used the left outer join, which is by far the most important and most commonly used join type in Power Query. But before we move forward, I wanted to give a quick high-level overview of the other join types that exist in Power Query, just so that you're aware of them. A left outer join keeps all the rows from your primary table and brings in the data only where matches exist from the lookup table. We've already covered this in quite a lot of detail. An inner join keeps all the rows that appear in both the tables. For example, your primary table has products A, B, and C, and your product master or master table has products A and B. The result of the inner join will show a table with products A and B only. This is useful when you want to remove any rows that don't have a valid match. In short, it keeps only the intersection of two tables. Then we have a full outer join. A full outer join keeps all the rows from both the tables regardless of whether they match or not. For example, your primary table has products A, B, and C. Your master table has products B, C, and D. A full outer output will show a table with all the products A, B, C, and D. This join is perfect for reconciliation tasks, for example, when you want to see everything that appears in either table, including the mismatches and gaps. Then we have a left empty join. A left empty join returns only those rows in the primary table that don't have a match in the lookup table. For example, your primary table has products A, B, and C. Your master table has only products A and B. A left empty join output will show a table with only product C. This is ideal for catching unmapped items, new products, or data quality issues. It directly answers the question, what's missing in my lookup table? We kind of tackled this situation with the left outer join as well in our previous video, where we replaced the null values with category name placeholder in the final step of our primary query. After that, we have right anti-join. A right anti-join does the reverse of the left anti-join. It returns only those rows that are in the lookup table but don't appear in the primary table. Let's assume you have a primary table which has products A and B, and you have a master table or a lookup table which has products A, B, and C. The output of a right anti-join will show only rows for product C. This is useful for finding discontinued items, unused master data, or records that never show up in the transactions. Lastly, we have right outer join. A right outer join keeps all the rows from the lookup table and only the matching rows from the primary table. It's rarely used in business analytics, but can be helpful when your master data is the main driver and your transaction table is a secondary table. When you face a merging or a data challenge, always start with the left outer. 95% of the time, left outer will be able to solve the problem. But just in case if it doesn't, then you can explore the other join types. Next, we're going to look at a powerful transformation about unpivoting columns. But before we do that, it's important to understand the concept of data structure. I have two tables here. Both these tables have exactly the same underlying data. For example, if I sum up all the amounts in these two tables, I will get exactly the same number, which shows that the underlying data between these two tables is exactly the same. However, these tables look quite different. In the first one, the months are arranged across columns, with each column showing the sales for that month. In the second table, the months are listed in one column and the sales values are in a separate other column. For the purpose of this course, we're going to refer to the structure on the left as the white table structure, because it has more columns and less rows. For the one on the right, we're going to refer to it as a vertical table structure or taller structure, because it has lesser columns and more rows. When working with Power Query or data analytics in general, you should always organize your data in a vertical structure. This can make your queries more efficient. It can also improve the processing speed, especially if you're dealing with large data sets. So how do you decide if your data has been structured appropriately or if there is a further room for verticalization? When structuring your tables, you should ensure that each column of your table contains a unique nature of data. If multiple columns in your table have the same nature of data, this means that you can further verticalize your data structure. Let's work with an example. Here, I have a small data set with columns for product name, region name, and then I have 3 columns for Jan, Feb, and March. Each of these columns show the same exact thing, that is the sales values. Since these 3 columns have the same nature of data, it indicates that there is a room for improvement and we can verticalize this table. Rather than splitting them across 3 columns, we can create one column for the month name and another column for the sales values. The revised verticalized table will look something like this. In the next exercise, we will convert a dataset from wide structure to a vertical structure using Power Query's Unpivot feature. The dataset we will use for this exercise is in this file called unpivot_exercise. Let's open the file to get an overview of the dataset. We've got a column for product code and product name, followed by 4 columns showing sales for January to April. This dataset is clearly in a wide format. We can convert it into vertical or long format. Instead of having separate columns for each month, we can have one column for month which shows the month names, and next to it we can have a column for sales values. In other words, we want to unpivot the months columns, and we can easily do that in Power Query using the Unpivot Transformation. Let me close this file, and I'll set up a new Excel workbook and load this dataset into Power Query to start the process. Alright, I have loaded the dataset into Power Query Editor. When it comes to Unpivot Transformation, you need to remember 2 important terminologies: anchor columns and attribute columns. Attribute columns are the columns that you want to unpivot. In this case, these are Jan, Feb, March, and April columns. Anchor columns are the columns that you don't want to unpivot. You want to keep them fixed and untouched. In this case, the attribute columns are the product code and product name. Broadly, there are 2 ways in which you can perform the unpivot transformation. First option is to unpivot the attribute columns directly. Basically, we will select all the attribute columns, right-click, and then go for the option Unpivot Only Selected Columns. That will convert your table into a tall structure. The second option is to unpivot the attribute columns indirectly. In that option, basically, you will select the anchor columns, right-click, and then go for the option Unpivot Other Columns. Both the options give the same end result, but there is some difference in the underlying M code that gets generated. In this approach, which is option 2, Power Query is performing a function called Unpivot Other Columns and hard-coding the name of the anchor columns, that is product code and product name. Whereas in the first approach, which was unpivoting the attribute columns directly, the M code was slightly different. Let me revert back to the first approach. I'll cancel this step, then select the attribute columns, right-click, unpivot only selected columns. Here we can see that Power Query is performing a simple unpivot function and hard-coding the names of the attribute columns. For now, let's go with the second option, in which we selected the anchor columns and went for the unpivot other columns. Now I'm going to load this query into a pivot table. Let's set up a pivot table with product names in rows, month name in columns, and value in the value section. I think I should rename the attribute to something more meaningful. So I'll go back into my query. And as the last step of this query, I'm going to rename attribute to month name. Let's reload it. And now in the pivot table, I will have a new field called month name. I'll drag it to the columns. Now, as usual, let's explore what could go wrong. Let's assume you receive a revised file from your colleague. And this time, the file has an extra anchor column. Let's say we have a column for category name. I'm going to save the file and close it. Now I'll go back to my pivot table. And refresh the pivot table. And now it shows an odd picture. It shows category in the month name field. So what's happening? Let's dive into the query to find out. Everything looks fine up to the change type step. But at the unpivot step, the table gets messed up. This is because Power Query unpivoted the category column, which it shouldn't have. The category column in this case is an anchor column. It's a fixed information column. It shows category name of each and every product, which is a unique data point. No other column in the table shows that. So this should not have been unpivoted. It's an anchor column. But the M code for the unpivot step only listed product code and product name as the anchor columns. So Power Query assumed that every other column in the table was an attribute column and unpivoted all of them, including the category. And that completely reshaped the table in the wrong way. So what can we do to fix this? Should we go for an approach 1, in which we unpivot the attribute columns directly without giving any reference to the anchor column names in the M code? Let's try it out. I'll delete both of these steps. And then I will select the attribute columns, right-click, unpivot only selected columns, and rename the attribute to month name. Let's close and load. Refresh. And now it works fine. Also, let's test out this setup once more. I'm going to add one more anchor column. Let's save the file, close it. Now, if we refresh the table, It's working fine. And we also have a field for sales rep, which we just added. If we want, we can bring it into the pivot table as well. So this setup works quite well, even when we have new anchor columns. But let's say next month, we've got a new attribute column. We've got the sales data for the month of May. If we refresh this table, then what will happen? Let's test it out. I will again open our source file. And here, I'm going to add a column for the month of May. And I'll just put some random values for now. Save the file and close it. Now let's try refreshing the pivot table. When we refresh the pivot table, we do not see the sales values for the month of May at all. Instead, May is appearing as a separate field in the pivot table, which is clearly not a clean way to structure our data. All the months should come under the month name field, so that when we put the month name field in the column section of the pivot table, all the months should appear here. Let's go into the query to inspect what's happening. Until the change type step, everything looked fine. On the unpivoted step, the table gets messy, and the May column is being set up as a separate column, which is clearly not what we wanted. This is because Power Query is not unpivoting the May column at all. The May column, like other month columns, should have been unpivoted. But it's not getting unpivoted because if you look in the M code, only Jan, Feb, March, and April columns are listed as the attribute columns. So Power Query assumes all the other columns, including the column for the month of May, is an anchor column and does not unpivot it at all, which deshapes and disarranges our table. All in all, if you expect that new attribute columns will be added over time to your dataset, you should use the second approach. That is, you select the anchor columns and choose the Unpivot Other Columns option. If you expect that new anchor columns may appear in your dataset, but there will be no new attribute columns, then the first approach will work. That is, you select the attribute columns directly and unpivot them. But in many real situations, you won't be able to guarantee either scenario. You might get new anchor columns as well as new attribute columns in your dataset in future. So how do we handle that? In simple terms, we want to tell Power Query to do this. We want to tell Power Query that please have a look at our entire dataset, identify how many anchor columns we have and how many attribute columns we have, and then please only unpivot the attribute columns and leave the anchor columns untouched. This logic sounds quite simple in plain English, but the problem is that Power Query does not understand English. It understands a different language, which is called M code. So if we learn a little M code, we can translate this logic into Power Query's own language, into instructions that Power Query can follow. And then Power Query will run this automatically every time the data changes. And once you know how to translate ideas like these into Power Query's own language, your queries become stronger, cleaner, and far more robust. And we are very close to learning that. In this lesson, I will walk you through one more common scenario you will face when handling or consolidating data from multiple sources. Sometimes you might get data on different sheets of the same workbook. Like in this case, I have a file with 4 different sheets. Each sheet has a particular month's data. I want to consolidate data from all of them into one table using Power Query. So I'm going to close this file. I'll set up a new Excel workbook. And I will connect this workbook to the source file using Power Query. To solve this problem, we've got 2 approaches. The first approach is to set up each sheet as a separate query and then consolidate all the queries using the Append feature. Let me show you how it can be done. On this screen, I'm going to select multiple items and then I'll select all the sheets. Then I'll go to Transform Data, and the data from each sheet will be loaded into Power Query Editor as a separate query. Now I can set up a new query and append all the tables together. Here's how it can be done. I'll select any query, then append queries as new. Three or more tables. This approach will do the job for now, but it's not expandable. If new sheet gets added to the source file in future, that new sheet will not be automatically included in our consolidated table. We need a solution that takes care of the new sheets as well as and when they are added. This takes us to the second approach. In this approach, we don't need queries for all the sheets, so I'm going to delete them and leave only one query. So we're going to work with only one query. I'll call it console. Let's inspect what this query is doing. In step 1, it's connecting to the source file. In the second step, it's opening the April sheet. And then it's promoting headers and changing the data type. We don't need the query to open the April sheet at all. So I will delete all the steps and leave only the source step. At the source step, in the preview grid, you can see a table with metadata of the source file. It shows how many sheets does this file have, what are the names of those sheets, whether the sheet is hidden or not, etc. The important column here is the data column. This column includes data from each one of the sheets. If you want to preview the data inside each of the sheets, you can just select the cell within the data column, and you'll be able to see the preview of the data below. For example, this table has the January data. This one has the February data. This one has March, and so on. If I expand this column, it will open each one of these data tables and stack them on top of each other. So let me first delete all the other columns. Now I will click the Expand button. I will uncheck this option and click on OK. And this will bring the data from each one of the sheets. From here onwards, the process is not too complicated. I can promote the first row as headers. Then I need to remove the rows that contain headers from each one of the sheets. There are lots of ways to do that. I will take the simple route. I'll just uncheck the product names from this column, and this gives us the combined table from all the sheets. Last thing I need to do is rename the first column and call it month. Let's go ahead and load this query as a table. This approach kind of solves the problem that we had with the earlier approach. That is, if new sheets come up, they will automatically be included in the consolidation. Let's test it out. I will open the source file, and here I'm going to create a new sheet for the month of May. Let's save and close it. Now let's refresh our consolidated table. And voila, it works. So it seems like this setup is working quite well, at least from the consolidation perspective, but there are some very important watchouts. The first watchout is about the sequence of columns in the source sheets. If a new sheet comes up which has columns arranged in a different sequence, that can corrupt your consolidated data. Let me show you how. I will go to my source file. Let's assume we have a new sheet for the month of June. And in this sheet, we have columns arranged in a different sequence. We first have the quantities column, then we have the value column, and towards the end we have the year column. Let's save this file, go back to our consolidated table. Let's refresh it. Although the data from June sheet is flowing through, but it's getting mapped incorrectly. the quantities are mapped in year column, the amount is in quantities column, and year is in value. And right now, since our consolidated table is small, we can spot these inconsistencies with naked eye. But if we were working with a larger dataset, we won't even be able to catch these discrepancies. Let me show you another problem that can happen. Let's assume we have a sheet for the new month now. This time the data on the sheet and columns are in consistent order, but the sheet is placed in the beginning of the workbook rather than at the end. Let's save this file, close it, and try to refresh our consolidated table. And it gives us an error saying the column January of the table was not found. Let's go into the query to inspect what happened. I'll start from the bottom to see which step exactly does the error happen at. The error happens at the change type step. When we created this step while building the original query, the first sheet in the file was January, and therefore the name of the first column after promoting headers was January. So the change type step was taking the January column and applying a text data type to it. But now the output of the precedent step has changed. The first column is now called July. And therefore the change type step does not work because it's unable to find a column called January. In the rest of this course, we're going to refer to this type of situation as the change type pitfall. One option is to remove this step altogether. Let's try it out. Even if I do that, on the final step, the query is again going to fail. And that is because in this step, we were renaming the January column to month. Now, there is no column called January. So again, the query breaks down. The issue here isn't just the errors themselves. The deeper problem is that these kind of source data changes like column name tweaks, sheet reordering, or shifts in column positions of the data, they happen all the time. And if our queries aren't built to handle these changes automatically, we'll end up wasting a lot of time fixing errors every time we refresh the data. This leads us to discuss another important concept that we'll need to keep in mind because we'll be referring back to it throughout the course. There are two types of errors that can happen with your queries: the silent errors and the blocking errors. Silent errors are dangerous because they can corrupt your data without any warning. In our first example, we had a new sheet for the month of June, which had the columns in a different order. Power Query did not flag it. It simply combined the tables and produced incorrect results. We caught it only because the dataset was small. But with larger tables, this can slip through unnoticed, and you could end up reporting incorrect numbers to management. Blocking errors are the ones that completely stop your query from refreshing. In our second example, the change type step broke because it could not find a column called Jan, so the whole refresh came to a stop. The good thing is blocking errors don't silently mess up your numbers, they make themselves obvious. But if they keep happening and we don't add any guardrails, they can become a real time sink. Every time you try to refresh a query and a blocking error happens, you'll end up spending time first looking for the step that caused the error, then figuring out why it happened, then fixing it, and then trying to refresh again. As we move through the rest of the course and look at more errors and pitfalls, we'll keep coming back to these two terms. If we run into a silent error, we will always need to add a guardrail. There is no exceptions. Silent errors can put the accuracy and credibility of our data at risk, so no exceptions there. If we hit a blocking error, we'll handle case by case. If adding a guardrail is simple, we'll add it. If it makes our query too messy, then we'll have to at least make sure that the error doesn't cause a time sink every time we try to refresh the query. Here's a quick recap of this module. In this module, you work with more advanced transformations that span across multiple tables, files, and structures. But more importantly, for each of these UI-based transformations, we also saw the watchouts, the assumptions and the pitfalls that can cause these queries to break or behave unexpectedly. This naturally leads to the next question: how do we safeguard our queries against these kind of issues? That's where smart use of M-code comes in. In modules 4 and 5, we'll focus on understanding what's happening behind the scenes and how to design queries that are more predictable, scalable, and robust. See you there.